It's my great pleasure to introduce this anchor point on early detection of emerging technologies using machine learning and burst detection. I'll be very curious to hear about these burst detection business. So it's my great pleasure to welcome my ex-PhD student, who's now a professor at Concordia, Andrea Schiffauerova. And I would call Ali my academic grandson now. Ali, and I'll mispronounce your name, but Ghaemmaghami. You can you can correct me in a sec. Who's a student of Andrea at Concordia. And we will have some comments and discussion with Ashkan Ebadu, who's a senior research officer at the NRC, National Research Council of Canada. So the presentation will focus on approaches for as the title said, the early identification of emerging technologies, which might be very interesting from a point of view of public policy, but also on ecosystem management. So there'll be a case study on artificial intelligence, which is always in the news. And this morning, the news were about the energy costs associated with artificial intelligence and these chat GPTs of the world. So we're very on the topic today, not on energy, but on the use of AI. So it will explore burst detection methods, machine learning techniques, deep learning approaches, and how can they be applied to predict and recognize emerging technologies at a very early stage. So Andrea, if you want to say a few words before Ali presents.
Yeah, I guess you introduced it well, so I will not go into big details. Just this is part of the project, which is like early detection of technologies, which is sponsored fully by 4.0. And this is only part of it, which is focusing on the burst detection. And yeah, I guess the student can start and talk about it, and then we will have more discussion about it. So I guess Ali can start.
Okay, Ali, tell me how to pronounce your name and then start.
Hello, Catherine, and hello, everyone. Thank you for your introduction. My name is Ali Ghaemmaghami. It's a bit difficult for
Ghaemmaghami.
speakers.
Okay, yeah. Sorry, Ghaemmaghami. Thank you.
Like are in French. Yeah. I'm ready to present my presentation. Just before we start, I wanted to make sure that everybody can see my presentation well. It's okay? Okay, thank you very much. So, as Dr. Catherine said, we are going to present the idea of early detection of emerging technologies using machine learning and burst detection. My name is Ali Ghaemmaghami, and I'm under the supervision of Dr. Andrea Schiffauerova and Dr. Ashkan Ebadu at Concordia University. Concordia, actually, Institution of Information Systems Engineering. So we are going to start presentation. Okay, this is the outline of our presentation. I'm going to go with introduction first, and we go a little bit about the literature review. Then we discuss about the data. We then go to the main objective of our work, which is prediction of sustaining emerging technologies using burst detection and deep learning. And we talk about methodology, results, and we conclude with limitation and future work direction of our study. First, we talk about the introduction of our work. Firstly, we are going to talk about emerging technologies. Emerging technologies have the potential to change technological paradigms and existing socio-economic practices. There are many definitions about emerging technologies in the literature. one of which that has been accepted by many researchers is the definition of Rotolo and his colleagues at 2015, which defines emerging technologies by 5 main attributes of radical novelty, relatively fast growth, coherence, prominent impact, and uncertainty and ambiguity. We focus on this definition that has been accepted by many of the researchers in this area. As you can see, the trend of documents with the topic of emerging technology in the database of Web of Science has been very positive, and it has been gathered many of the researchers around this topic. So now that we know that the topic is very important, now we are gonna try to early detect emerging technologies. Early detection of emerging technologies can empower research and development and policy making with knowledge, intelligence, and opportunity. As you know, the rapid pace of technological changes make fast detection of emerging technologies increasingly valuable for leveraging big data. So, now we want to discuss about the list view of the book, and then we are going to talk deeper into the objective. There are different methods of detecting emerging technologies in the literature. We have categorized it into 5 approaches, methods of detecting and identification of emerging technologies. First is lexical-based approaches. Second is bibliometric-based approaches. The other one is indicator-based approaches. And we have machine learning approaches, especially in the last few years. And we have hybrid approaches. They are not completely distinct approaches, and they may have some overlaps between themselves, which we are going to talk a little bit about these approaches in the next few slides. So, first kind of approaches are lexical-based approaches. Lexical-based approaches are focusing on analyzing term-related information to identify key terms and trends, like keyword and keyword analysis approaches. As you can see, there are some of the main research that has been worked on these approaches in the table. For example, Wu and Liu have been presented their work about patent keyword map analysis that was able to assess technological trends in hydrogen energy in 2014. Or for example, Furukawa and his colleagues in 2015, they used analysis of chronological changes in research teams with the application of discovery and identification and analyzing the evolutionary process of new technologies in rapidly expanding research domains. And we also have, for example, Young and Kim about keyword-based models and content-based patent analysis for tracking development in technologies using technological keyword-based analysis of patents, or Weismar and Pezenka for the application of content analysis with longitudinal latent semantic analysis of keywords. Nowadays, this approach has been supplemented with more complex methods, and we rarely see just this approach to be able to kind of assess the trends very well. And most of the approaches has been used this approach alongside with other approaches. So we have bibliometric-based approaches. Bibliometric-based approaches use analyzing scientific literature to identify patterns and trends in research and development area, like, for example, citation analysis, co-citation analysis, and social network analysis. We have gathered some of the work. For example, we can see that Dame et al. Have been introduced bibliometric and patent analysis in 2006 for technology forecasting in some emerging technological sectors, and with other work and methods like topological measures, citation network methods, or, for example, logistic growth curve approaches, and other approaches that has been focused on bibliometric approaches to analyze scientific literature to detect emerging technologies. Then we have indicator-based approaches that focus more on using various metrics to detect patterns and trends in research and development. For example, they use number of publications, patents, or specific keyword frequencies in their work to detect emerging technologies. For example, Porter and DeTemple use keyword frequency in abstract as a measurement of emerging technologies to detect emerging technology in bibliometric databases in 1995, or other methods that focus more on metrics as the most important measurement of emerging technologies. For example, we have Go et al. In 2011 that we used 3 metrics of bursting terms, new authors coming to the area, and interdisciplinary references to identify emerging research areas. Nowadays, like lexical-based approaches, these indicator-based approaches has been used within other methods, not just by one single category of approaches. Now we have machine learning approaches. They usually automate the detection and analysis process to be able to do predictive modeling with the usage of machine learning techniques, such as data mining and natural language processing approaches. For example, as we can see, we have Zhu that use dynamic influence model, DIM, and citation influence model, CIM, with MTLS SVM to detect topics and predict future values, or with other supervised and semi-supervised or different methods of machine learning that has been developed in the last few years to be able to identify emerging technologies in both, for example, patents and papers studies. We should acknowledge that they are powerful methods, but they have their own limitations when we are going to use them. And lastly, we have hybrid approaches that combine different techniques that we talked about before to be able to identify emerging technologies. For example, we have Avila, Robinson, and Miyazaki in 2013 that use bibliometric indicators, social network analysis, and multivariate statistical methods to be able to detect technological emergence with the usage of citation data. We have the work of Wang and also Carly that use bibliometrics and growth indicators to detect research topics or later, for example, patents to detect emerging research topics and emerging technologies. Or, for example, we have the work of Dr. Ebadu and his colleagues that use deep learning, NLP, and weak signal analysis to be able to early identify technological emergence in the field of hypersonics with the usage of scientific papers. So we talked about these emergence detection methods. However, we should acknowledge that these methods still have their own limitations to detect emerging technologies. One of which can be subjectivity risk due to manual interventions. Many of these approaches highly depend on the manual data that we give to themselves to be able to detect these emerging technologies very well. Many of them have limited scalability, so they cannot be used when we are going to try with high volume of data. Many of them lack quantifiable metrics to determine the performance of the process of emerging technology detection. Some of them lack predictability or low accuracy rates for future predictions, even if they have those quantifiable metrics. And many of them are unable to accommodate various data types. They only, for example, limited to patents or papers to do the emergence detection process. So because of these limitations, we are going to kind of mix and use the burst detection process and add it to the emergence detection process. The idea of detection of burst terms, which we know as burst detection, firstly introduced by Klinberg in 2022. Then the idea of using burst detection in the emergence technology detection process used firstly in 2011, as we talked a little bit about it, by Gu and his colleagues. They used the measurements of a burst of keyword usage as one of the needed indicators of emergence for a specific term to be emerging. Then the birth detection process has been developed over the years, and they use Klingberg's methods in different applications, for example, to detect bursty terms or bursty topics in Twitter and newsfeed by different works. Nowadays, we have seen, and after the Kollingsberg works, that this method has been kind of tweaked and improved by, for example, proposing new burst detection methods based on stock market analysis that may be more suitable for scientific documents to be used. This method has been proposed by he and Parker in 2010, and this method has been tweaked to be applied to predict the future computer science topics by Tattershall and her colleagues in 2020. So we are going to add the idea of burst detection to the idea of emergence and predict the sustaining emergent technologies using bursty detection and deep learning. So now we are going to talk a little bit about the data and then the methodology and the results. We focused on two different data types, patents and papers. The data source of patents is Lens database, and the paper are DPLB database of papers. The search query is artificial intelligence words like artificial intelligence, deep learning, and machine learning to be found in the titles and abstracts of patents and papers. Now we are going to talk a little bit about the methodology and the results of our work. We are going to use burstiness, which means that how much we can say that a term have burst and kind of increase in the usage. For example, patents or paper database, we are going to calculate emergence through burstiness, and then we are going to predict the future prevalence of the identified emergent technologies using burst detection, and then apply machine learning and deep learning for predictive purposes. So we're gonna know that burstiness are terms with a sudden increase in usage and popularity within a certain time frame, as opposed to those terms that are simply consistently popular over time. So that's the main difference between bursty term and other terms. We have a sudden increase in usage against, for example, being popular over time kind of uniformly. This is the process of emergence detection using burst detection. We have data processing, keyword extraction, and we apply MACD as a kind of burst detection method to predict emergence using MACD features. We talk about these in the next few slides to be able to know the rising emerging technology terms which are sustainable. So we have our first step, term preparation. We have keyword extraction. We use count vectorizer as our vectorizer to be able to detect terms. And then we exclude general English terms and we exclude non-AI terms, which are kind of noisy, and we want to filter them to be able to increase the accuracy of our model. Then we are going to filter and normalize these terms, the remaining terms. We are going to remove rare terms over time, which, for example, they have had limited usage, for example, 1, 2, or 3 times. We kind of excluded these terms, and we have a double normalization, document and token-based normalization, which means that the term frequency counts each year divided by the total number of documents in the year, and each term frequency counts divided by the mean number of tokens per document. After this double normalization, we have each normalized element in the year term matrix, which we kind of map these normalized matrix to a measurement of prevalence. So that's the one that we are going to predict in the future. So we are going to talk a little bit about MACD. The element of MACD is kind of burst detection with the idea of stock market. And these elements, we talk a little bit about them. Firstly, we have exponential moving averages. We have the idea of moving averages, and the exponential moving averages is kind of a moving average that use a specific kind of calculations. For example, you can see the frequency of, for example, topics or terms in a topic, and we have the frequency that changes very much, but the idea of moving average lets us to have a smooth kind of indicator that changes around time, but smoothly. And you have, for example, we have EMA with the time frequency of 9 days that lets us catch the trends a little bit with the idea of exponential moving averages. So we have moving average, convergence, divergence, which is MACD. And the idea is that we have 2 different EMA, or we have had like exponential moving averages, and we have a line moving average, and we have a short moving average. MACD is going to subtract these two elements and amount from each other. So, for example, we have long EMA of like 26 days, and we have a short EMA of like 12 days. And the difference can help us catch the trends a little bit better. For example, you can see the frequency that when we have positive trend, we can say that we have MACD, which is positive, or negative. It depends on the trend, and the amount of MACD will change based on the trend of our emotions. So we have a signal. Signal is based on three elements, N1, N2, which is the number of days of short-term EMA, long-term EMA, and we have now a third element, N3, which we kind of want to see the whole picture with signal. So signal would be the exponential moving average of the MACD. So that may be a little bit difficult because it's kind of technical, but I'm going to try to talk about it. For example, with the usage of the figures, as you can see, we have a trend that can be smoothed by MACD line and signal line. So signal is the one that can be used to catch the trend. All of these items can catch the trends, and we are going to know the trend by these quantifiable variables. So the last one that can be used and will be used in our work is histogram. The histogram is going to be calculated when we subtract signal amount from the MACD amount. And this histogram calculation can be used to see how much a trend is powerful. So when we have a positive histogram, it means that the trend is positive. And when we have a negative histogram, it means the trend is downward and the trend is negative. And when the amount of histogram is high, it means that the trend is powerful. For example, if we have a high positive histogram, it means that trend is very powerful and upward. And when we have a negative histogram, again, with a high amount of value, it means that the histogram is, it means that the trend is kind of downward, but very powerful. So we are going to apply these ideas around the emergence idea and to detect emerging technologies. For example, we can see that when there is a shift in the histogram from negative to positive, there may be an emergence signal, and we should pay more attention to that trend that can be a signal of a new trend and new kind of usage of that word or frequency, increase of the frequency of the word in the real database. So we talked about these ideas to know that now we are going to say that the burstiness is being calculated by the histogram and a measurement, a kind of scaled version of histogram. So we now see the burst detection as an indicator of emergence potential, which can be calculated by calculating the histogram of a different term over time. We also want to have time series features as input of the feature of our machine learning methods. So for example, we talked about long MA, short MA, signal, and histogram values. All of these things that we talked about can be used as a feature of our model to be able to predict the future trends of these terms that can be signaled as emergent technologies if we have, for example, positive trends, maybe. We also have different scales of these values. For example, standard deviation, mean, minimum, and maximum of these previous values as another features of our model to be, for example, input features of our machine learning models. So now we are going to predict the emergence using MaxT features. The X part would be time series features. The Y or Y part would be the smooth value of term prevalence during the time, which could be higher or lower than the prevalence during the previous time based on prediction interval. And we have the time span of the analysis, which would be 21 years, the range of data around 1990 to 2020, with the prediction interval of 3 years. So we are going to predict the 3 years ahead of us. We use data time split as the method of the time split. So we have training data of the year 2010 to 2019 to test data of 2020. And you should know that the test data of 2020, which kind of measures the 3 years ahead. For example, it see that the trend and the smooth value of the Y that we talked about it would be higher or lower in the next 3 years, which would be the year 2023. We are going to apply different classifiers: random forest, gradient boosting, XGBoost, and multi-layer perceptron MLP neural network classifier to be able to predict the future prevalence of the terms. We are going to evaluate our models with these machine learning metrics: precision, recall, F1 accuracy, and AUC area under the curve, with the possible outcome of true positive, false positive, true negative, and false negative. And also we have support, which is the number of actual occurrence of the class in our dataset. So we have the patent results of the model. We have the random forest, gradient boosting, XGBoost, and multi-layer perceptron. Our results showed that the AUC of multi-layer perceptron was better than the other models, relatively the same with random forest, but higher than the other two. And we have the recall, which is one of the most important measurements of the emergence. We have 85%, around 85% for MLP model, and around 76% for the random forest, which again, the recall of the MLP model was better than the other models. We have the confusion metrics and the results of the multi-layer perceptron metrics. You can see the precision and recall of each class. We have the falling terms and we have the rising terms, which means that, for example, a term would be higher in popularity, which is rising, and falling, which is obviously falling. So we can say that, for example, we have had the accuracy of around 70% and weighted F1 score of, again, around 70% for the multi-layer perceptron model. We have the paper results. Again, we have the MLP model that outperformed the other models in both AUC and recall, which were the most important metrics of our work. And we have the accuracy of around 80% and F1 score, weighted F1 score of around 78% for the MLP model. We have the figure of the results that you can see. There is a difference between MLP model and the other models, but the other model works relatively the same. XGBoost, gradient boosting, and random forest. And we have also compared the recall of the rising technologies in patents and paper, which again, MLP model worked better than the other models. And we're going to say that the MLP dominance across diverse data sets in the predictive modeling can be assigned that the MLP model can be used in the process of emerging technology detection and can capture the complex models and behavior of emerging technologies. The MLP model outperformed the other models in the recall metrics and is also work better than the other AUC metrics depending on the dataset. We can say that we can apply the MACD in the process of emerging technology detection, and the model that has been performed can have acceptable metric results. We also have time split data that we can say that it should be used in time series problems such as emerging technology detection problem, which was not in the previous works of the first detection. But when we are talking about emerging technology detection, we should use these time split models because we have the time series problems and they should be kind of tested in the real world data. So we have conclusions that we are going to talk about the implications of our model. As the theoretical point of view, we can say combining burst detection, emergence detection, and machine learning can have positive results. Burst detection and burstiness can be used as an indicator of emergence in the real world. And MACD and other related indicators can be input features for machine learning problems for the idea of emergence detection. Also, we have the MLP and deep learning models that have had the highest recall and accuracy rates than the other conventional machine learning methods. And we have applied time split in the data in the process of emergence detection that lack the literature around the idea of burst detection and emergence detection. From the practical point of view, we can say that stakeholders can use burst detection, emergence detection, and machine learning to have a better insight both around the burstiness and the emergence levels, and also the future prevalences of these emergence technologies. We can also say that deploying machine learning methods, especially MLP methods with a higher accuracy rate, can assure stakeholders for its usage in real-world problems. However, we have had our limitations in our work. We just use a specific domain in our study, which is the AI. And we also applied our model into only one data set at a time, not, for example, both data sets. We have had, for example, paper data sets and patent data set. We just have had their own results and we didn't combine them. We also have had the problem with noisy terms. Also, although that we have had some methods to reduce noise in our works, we still have had some noisy terms in the final results. We also have the model have had the risk of overfitting and also lack interpretability because of using the MLP models. So the future work directions can be cross-domain validation that prospects to applying these approaches to diverse fields and also applying different data types that can be applied in one single burst detection problem that can use both patents and paper data sets, or even more data sets, for example, findings or news in just one single problem. And noise detection and noise reduction methods can be applied with advanced processing and data cleaning techniques to reduce the noise. And also mitigating overfitting and enhancing interpretability can be applied by, for example, regularization techniques and techniques like LIME, which is local interpretable model agnostic explanations to increase interpretability. Okay, thank you very much. I hope you have enjoyed the presentation, and I'm ready to answer your questions.
Wow, thank you, Ali. That was just so comprehensive. I have plenty of questions, but before that, I want to hear Ashkan. Maybe you can comment on the presentation and maybe on how it can be useful within your work as well. Maybe stop sharing your screen, Ali, unless, Ashkan, you need it. We can't hear you just yet, Ashkan. Even though you're not on mute, we can't hear you. Nope, still no sound. In the meantime, Ali, can you stop sharing your screen? Ah, excellent. Okay, it seems that we're continuing in the technical problems today. Ashkan,
I hope you can hear me now.
Yes, now we can. Excellent.
Okay, I changed the microphone to the webcam.
It's one of these days, you know.
It
It's
is.
May.
Thanks, Eddie, for presentation. And maybe I can also add some words to the work. It's one of the lines of research that we are proceeding at the NRC in collaboration with Dr. Schiffauerova and the team. So the focus, well, the general theme I would say is on how we can leverage the techniques that are already established in other domains, like the one that Ali presented today was already defined in the stock market analysis, and then how we can use them and empower them by advanced techniques, including AI, to provide better results at the end of the pipeline. So this is one of those. There are some other lines of research, including other techniques that we are working on. And each of these has their own advantages and drawbacks, I would say. So we can discuss further the limitations and advantages of Ali's works today in the discussion section. But how we can use it, you can imagine the usage is super wide. Like you can use it, for example, for strategic decision making. You can use it for foresight. You can use it to identify emerging technology in advance, and then a lot of different usages. And as Adi mentioned, like it also ties with the data that is used in the backend. I know we're short in time, but so I cut it right here. But super happy to answer any questions that you would have.
Do you want to respond, Ali, or should I go ahead with? I had some questions regarding one of the first graphs that you're presenting about the origin of emerging technologies. You presented a first graph. I was just wondering what is the definition of emerging technologies in this data, and what's the source?
Yeah, actually, we have two different parts about the emerging technologies that you saw in the first figure. We kind of use emerging technologies and all the different formats of the word emerging technologies that has been used in the abstract and titles of the papers in the Web of Science database. So we wanted to see the whole picture, which is, we can say that the trend of using the term emerging technologies in the paper was positive. So that's the one idea. And the other idea is that definition of emerging technologies, which is kind of a diverse idea because we have different definitions of emerging technologies, one of which, and one of the accepted ones, is the Rotolo's work that defines emerging technologies with the pillar such as, for example, growth, coherence, novelty, and ambiguity. They have, for example, 5 different growth for 5 different pillars, and based on these attributes and pillars, they say that, for example, if a technology is emerging or not.
Mm-hmm. But for example, I could think of one of the possible application of what you have shown would be to inform, for example, Statistics Canada, which has a survey of advanced technologies, which includes both emerging technologies and advanced technologies. Say, okay, in your next survey, this should be on your radar because we see it clearly as emerging. So that could be another application that, Ashkan, sorry, I'm biased in Statistics Canada's way. The other question I had is, do you think that, your recall figures for articles was much better than for the patents? Is it because we're more avant-garde in the papers, and then it takes time to be in patents, and that, the patent world is more kind of, in French we would say normé or standardized, so there's less scope to be able to measure emerging technologies? And how do you explain the very stark difference in the recall results in your two figures?
Yeah, I understand if I understand your question, it can be a little bit subjective, but I give my own idea about why, for example, paper data sets work better. That could be some reasons. One of them is that I think the patents data sets, they have had, for example, we can say more ambiguity and uncertainty. When we are in the real world problems and real world kind of applications, we see patents.
I wouldn't go that way. I mean, we very much are in the real world in academia when we publish articles.
Absolutely. But in my idea, we can say that, for example, we have more uncertainty in patent data sets when we compare it to academia. Also, we have had different kind of databases. Different databases, they have their own, for example, way of presenting, their own way of, for example, categorizing data. That would be another way. We cannot kind of really compare different data sets because they have their own like features, we can say. That one would be another difference. So, for example, if we compare, for example, because there are many data sets and databases that have access to patents or papers. So, for example, if we have the same data sets from the same category and the same kind of database, maybe we can compare them. What I mean that they have noises in the databases, and maybe that's not the whole idea, that we can say that, for example, okay, academia works better, or for example, industry or patents work better. That's my idea. We can
okay, so basically you can compare within the patents world and you can compare within the academic world, but the two are so different that comparing the two is not necessarily relevant. Okay.
Can I jump in?
Yeah, please do.
Yeah. So, but I'm going to share my experience in that regard. It's also dependent on the data and the domain that is being investigated. For example, AI, which is highly evolving, rapidly changing. So if you focus on patents, as you mentioned, Catherine, like the process takes longer to get established, and once the patent is issued, then maybe the idea has already changed. I mean, in the academic field. Academic ecosystem. So based on that experience, what we found was for AI-related technologies, publication is not a bad source, but even better than that is funding proposals and news.
Andrea, any comment, or we open the floor because you know the research quite well, but any questions, Alvar, Amirali, Marie, or Pietro?
One, if I can. Do you hear me?
Yeah. Go ahead.
Thank you for the presentation. It's interesting to see this work. It opened my mind to other avenues. It's interesting. What I'm asking is, if I understand the process, so you pre-process terms, you have some term pre-processing, and you choose some terms. You have probably, because you said you wrote, you removed no terms not related to AI, right? I understand well? Okay, good. And so you based on term frequency, essentially, you apply the MCA, this is new for me, MCAD framework to this matrix, essentially. So this is what I understand. Which is interesting. This is used for financial stock markets, right? This model?
Yes, exactly.
Yeah, this is what I studied during your speaking. I tried to understand. So I find this interesting. The only point that probably you already now have think about it is what happened for new word. If I understand the process, I see there can be some process in detect new technology for which some new words appear, or sometimes we have new combination of words. This is really often important. We can see that there is a new technology which is a bigram of two other words, right? So essentially, the idea is new word. If you have EV filtering a word which is top down, so at the beginning you say, okay, the AI domain is made by these 1,000 words. So, but what happened if you want to use it in 2024? So probably you have already think about it. So I want to hear your reflection about the detection of new emergent technology that use words that are not still known. You know what I'm saying?
Yeah, if I'm correct me if I'm wrong about your question. For example, you are talking about completely new terms that, for example, maybe in 2023 or 2024, we have a new term that's been added into the AI ecosystem, for example, and how we can kind of detect that term, because the whole process is based on the history of the term and how it kind of fluctuated and changed. That would be one of the most difficult aspects of detecting emerging technologies, because most of the kind of methods rely heavily on the history of the terms. So, for example, a completely new idea, completely new term would be very difficult to capture. And the idea of burst detection is the one that we are trying to kind of apply, because that's exactly what we are going to detect. Burst detection means that a kind of burst and sudden increase of a term. So when we have a new kind of term in the technology, these bursty terms and the idea of burstiness is going to capture it as soon as possible. But it's even if we try burst detection techniques and these kind of things, it is difficult to capture it based on the history of events, because we don't have actually a history of those events, of those terms. And that's even more difficult when we are in a rapidly kind of changing environment like AI.
Can you jump in?
Yeah, go ahead, Ashkan.
So it's about the bigger picture that we are working with Dr. Andrea on emerging technologies detection. So back to your question, David, and I'm just adding some comments to what Ali mentioned. So burst detection is definitely based on terms, frequencies. It needs historical data. So there are some disadvantages here that you can count. One is in the beginning of the in the beginning years of the data, you cannot perform that well because you need historical data to detect burst detection. That's one thing. The other thing, like you mentioned, is that, okay, what about new terms that are being introduced to the data? So these are the weaknesses of the technique. But we are in another line of research that we are working on. We are working on convergence and divergence of emerging technologies. So like you mentioned, I'll give you an example. For example, we have a couple of different technologies that are getting converged to introduce a new technology. That's the idea. How we can do that? Completely different technique. So there we are working on graph neural networks. So it's a combination of network analysis and deep learning to detect those, new technologies that are being generated by combining previously known technologies. I hope we answered your question.
Thank you.
Okay.
Thank you to both. Thanks.
Excellent. Any other questions? Because I now realize that we're way over time. So just wondering if there are more questions. Please feel free to put your camera on and ask them de vive voix.
I know we spoke about it, like you briefly touched upon this, but say that what do you think the tendencies are, knowing that it's changing so rapidly? As you said, for example, it's not the direction, but like Catherine said, the topic for today was this, and ML has. I'm not going to say that it has drastically changed, but at least on the number of utilizations and the progress and applications in the past year and a half. So my question is more towards future applications, where we're going with a kind of a relatively advanced plug-and-play models, ChatGPT-like and open source. I don't know if you had any views on that, based on your topic, but adapted to the technology adoption.
If your question, I'm thinking about it in two different ways. Firstly, you're talking about the methods that we are going to apply, for example, like MLP models and more advanced methods, or you are saying that the results of our work, for example, what we predicted about the future, what term or technologies.
Mostly on the methods part.
Yeah, actually, I think these methods, like MLP models that we applied, can be used in by more advanced way. Like, for example, as you know, they are like more advanced way in like consequences and these kind of things. I kind of the term is eluded in my mind, but yes, there are different methods, especially in the area of deep learning and the area of NLP, that can be used in these models. That if we apply those models, we're gonna have better results even. So that's the area that maybe Dr. Ebadu is more aware of it.
Yeah, I can add a couple of words. Trying to answer your question at very high level, LLMs, yes, that's on the radar. We are using it in the analytical pipelines that we are building. But apart from it, like the general concern of the team is on, let's say, 2-3 main things, which is interpretability, fairness, and transparency. So we are also working on these 3 different directions using different techniques that you can imagine, but this is the umbrella of the thing. And one last thing is that we want to augment the decision. I mean, not to replace any decision maker, but to augment their decision using AI-powered decision support systems. I hope we answered your question.
Yes, you did. Thank you very much.
I have a little comment, but it's not, yeah, if I can, it's not really a question, but can be. It's about dataset, and there are several papers that have been published after the COVID, and scholars that have tried to change data, the source of data, to, in the idea to detect emergency technology, or they do not talk about emergency technology, but something related to real-time analysis, something like that. And the most of them focus on the fact that patent or papers or other survey has a time lag, right? And they tried Medium, so scientific blogs such as Medium or others, and they really find that was really efficient to use, because the publishing process is lighter, right? But it's still controlled, so there's not everything can be posted, right? It's years that I think about it and I want to try something, but I'm not yet done. I don't know if I have already think to use some source of data like that.
Yeah, definitely. That's a valid point. There is a lag in the publication business. The other potential data source that we're using is using, for example, archive. So there is no publication process in place. Might be a bit faster. The problem with blogs, generally speaking, is the validity of the source. So let's say at a scale, because you don't know who wrote it and is it really scientifically valid. So that's the problem. But yeah.
Okay. Right. Well, in that case, I think we can all go for lunch. It's 12:30. Sorry for the late start, but I think we've had a great discussion following your extremely detailed presentation. I think I'm going to have to take some time to re-watch it and make sure I understand everything. But I mean, thank you for sharing. Good luck on the continuation of the PhD. But you're well framed, and on my screen you're exactly between Andrea and Ashkan. So you're really well framed in my screen. So now you've all moved. So anyway, so have a great afternoon, and then we'll. There's another seminar very connected tomorrow. So
yeah, exactly. So see you tomorrow, Ashkan and Var. You're both there. And we invite you to participate also as audience.